Hello students, welcome to Microsoft Academy. So today we are going to look at a question that have to do with thermodynamics. Now the question here, it says that when 1 gram of boiling water with volume of 1 times 10 raised to the power minus 6 meter cube is converted into steam at a pressure of 1 atm. Now the steam occupies a volume of 1671 times 10 raised to the power minus 6 meter watts cube. The heat input is 2255 watt joules. Now we are asked to compute the external work done by the system and also the increase in the internal energy of the system. So here, let's start with the first question. First question says compute for the external work done. Now the external work done in thermodynamics is given as the pressure change in what? In volume. So where this is the same as writing P, our change in volume is V2 minus what? V1. So the pressure is given as 1 atm, but we are going to convert the 1 atm into the standard form, which is Newton per meter squared. So which 1 atm is equal to, so you have to take note of that, 1 atm, that is for the pressure, 1 atm is equal to 1.013 times 10 raised to the power 5. That is the pressure in Newton per meter square. So we expect to do that conversion because our volume is in meter cube. So now if we should substitute for the volume, our volume here, we have two volumes. The first volume is 1 times 10 raised to the power minus 6 meter cube, and the next volume is 1671 times 10 raised to the power minus 6. So the second volume is our V2, which is 1671 times 10 raised to the power minus 6 minus this first volume, which is 1 times 10 raised to the power minus 6. So if you should punch this in your calculator, you'll be having, for the work done, will be 169.17 joules. So that is our work done. So with this, we have gotten the work done. Now the next question says we should find the increase in the internal energy. So from our first law of thermodynamics, we have that the quantity of charge is equal to the internal energy plus the work done. So here we are finding the internal energy. So the work done, we move over to this place and we have that the internal energy is Q minus what? The work done. So that means the quantity of heat was given, which is the heat input, is 2000 and what? 2255. So we substitute 2255 minus the work done. The work done is what we just calculated, which is 169.117. So if you are to punch this in your calculator, this will give us 285.83 joules. So this is the internal energy. So this is how you solve question on thermodynamics. So next videos we'll be looking at different questions we can see also in thermodynamics. Thank you.